Concavity and the second derivatives test. I'm hoping that you did try the do now before you look at this video. If you haven't done that, pause the video and try the do now right now on your own first. If you make a mistake, you'll fix it. It's not a problem. But you're asked to draw the derivative of the function. So we have f of x and we have to draw f prime of x. The key idea is that we're looking for where there's relative maxes and mins. That is where there's going to be zeros for the derivative here. 0 here and 0 here. And you can also check for, it's what is the going to be the lowest point, for example. So I see that the function is increasing. Maybe it's better to use a highlighter. Is increasing here. So that means for that particular interval, I should have a derivative that is positive, that's above the x-axis. And then I see that the function f of x is decreasing on this piece here. So that piece needs to go underneath the x-axis. And then the function is increasing again from 3 up to infinity. So again, when I draw the derivative, then it's going to have positive values. It should be above the x-axis. Now transferring that, I'm going to now take, and obviously for me to go through 0 and then negatives and back through 0 again, it's going to have to curve up and hit the x-axis again. I see that the steepest this function is f of x is around here in between 1 and 2. So that means, if I eyeballed it, I kind of eyeballed it and say, the slope looks like it's a little lower than -2. Maybe it would have been better to go down a little further. But here at x is 2, that's where it seems to be the steepest. If I'm then drawing the second derivative of that, I'm drawing the derivative of the derivative. So then I'm looking for where this function now has maxes and mins. So this function here, my derivative function, f prime, has a minimum at 2. X is equal to 2, it looks about. So that means that my second derivative will have a 0 there. And if I then look at, f prime is decreasing here where I'm shading, that's decreasing. That means the second derivative will then be negative there. So it has to be underneath the x-axis. That would correspond to here. And the last little bit here, the first derivative is increasing on the interval from 2 up to infinity. So that means we're going to have positive values here for the second derivative. So similarly, if you look at the second problem here, I'm looking at, yes, I have relative maxes and mins here. So that's where the zeros would be. And then I just kind of eyeballed it a little bit. It looks like a slope that's a little bit greater than 1 on this part here. But that's where f is increasing, so that means those have to be positive values, and f is decreasing here. That would correspond to these negative values here, like that. And where it kind of changes its behavior, where it looks the steepest looks here. So that's going to give me relative max there, and the steepest here, it looks around there. So I'm kind of eyeballing it. That would be there, right? And then that confers down to the second derivative, where the steepest were. That's where my relative maxes and mins are. That's going to give me zeros here. And then again, interpreting in terms of decreasing and increasing. Now, in terms of terms, concave up is when it makes a cup, like an up. The word up is there. And concave down is like a frown. So it's like it rhymes with frown. It's just a way to remember the two, right? So if you look at your do now, then circle the correct answers or the correct word that completes the sentence. When the graph of f is increasing, f prime is going to be positive, hopefully. And when the graph of f is decreasing, we know f prime is negative. That is from the last unit. But if the graph of f is concave up, all right, so let's look where that happens. concave up happens here. That's concave up, which ended up corresponding to where f prime is increasing. And if you look even further, that's where the function is decreasing. Let's see if that goes over here. I can see that concave up looks about here, and there's also a concave up part here. And if I look at the first derivative, that would correspond to this part in pink right here. That is where it's increasing. The first derivative is increasing. And the same here. Look, that's the same x-coordinate here where that changes, the same x-coordinate down here. And if I go all the way down, what would that correspond to? That would correspond to this part of the second derivative and this part right here of the second derivative. All right, so let's see, keeping that in mind, those highlighted pieces. The graph of f is concave up when the second derivative is positive. So positive here. And the graph of f is concave down when the second derivative was, well, then that would correspond to, if I did concave down is right here in blue, which is the first derivative is decreasing, but that makes the second derivative negative down here. Okay, so that means then that the graph is concave down when the second derivative is negative. All right. And the graph is concave up when the first derivative is then increasing, because that would make the second derivative positive. And the graph of f is concave down when the first derivative is decreasing, which makes the second derivative negative. So let's see if this pattern makes any sense. It says predict the pattern, reading the pattern from left to right. So I have a slope, and I should say the slope of the pattern. So the slope of the lines are, look, this is negative. This is also negative, but less steep. Now this is 0, and this one here starts being positive, and then also positive but steeper, and also positive but even steeper. So we're going from negative to positive values. If I was doing that on a number line, the values themselves, so the value of the slopes would be increasing in values. So that's going from negative slopes to 0 to positive slopes, and steeper in each case, like if I'm going on the positive side. Now, if I look at it the other way around, so this one here for the next one, I have a positive slope, also positive but less steep, also positive but less steep, 0, negative, negative but steeper. So in this case, the slopes of this, in this pattern here, is decreasing in value. Decrease. I promise this is going somewhere. Decreasing in value.